Hello everyone, nice to have you here. Welcome to my presentation about how we used AI to analyze call recordings in our company. So first, let me briefly introduce B2 Impact. So we operate across Europe in the credit management space. We are rooted in the Oslo and we are present at the South Stock market, what reflects the scale of our company. So at the high level, we operate with debt at the different stages of its life cycle. Starting from the investing in portfolios through management of repayments to supporting other companies with their own collections. So what's important though is how we do it. We rely heavily on the data analytics and AI to support our decisions. So while debt management is what we do, the real story today is about the technology we use to make it in a more effective way. So, at some point, we realized that in our company we store a large volume of audio recordings. We started the project in Spain where we process around 1,400 audios daily, which is approximately 26 hours of data. At that scale, storing them in a WAV uncompressed files became costly in terms of storage and reading and writing operations. So we decided to incorporate a FLAC as an intermediate format. FLAC provides lossless compression, what significantly reduced the storage requirements while preserving the same audio quality. And it was quite important in our solution as the good audio quality impacts the good solution quality. So the plan was to take the audio recordings, transcribe them, and use the resulting text to extract some business insights using large language models. So our first use case was the quality control in the contact center. So our advisors need to follow strict legal and internal guidelines. For example, they need to inform that the call is being recorded, or they need to properly verify the identity of a speaker before sharing personal information. So previously, the process was completely manual. The employees needed to listen to the recordings and review them one by one, what was quite slow, expensive, and they could validate only small portion of data. Another use case were detecting compliance risks. So in the debt collection, the debtors may mention some sensitive situation. For example, they can say that they are in bankruptcy, or they can question the debt amount or the debt existence. And such situation requires some special legal handling. And if they are missed, they can cause some regulatory risk. So again, the process was manual. The advisors needed to report such cases manually, and then the compliance review them afterwards. So these initiatives comes with some practical issues. So I will walk you through the challenges we met in the project, and I will tell you how we solved them. So the first challenge was compliance. Before even we could touch the data, we needed to provide some formal GDPR assessment. So what may be interesting for you here is the requirement of transparency. So the speakers needed to be informed that the call is being recorded, and also that it may be analyzed by AI. Another requirement that touched us a bit is a data retention. So we needed to implement some rules to delete old results. Another compliance requirements comes with AI Act, European AI Act, that is something newer, let's say. And what was interesting here is the human oversight requirement. So this means that the process cannot be fully automated. So in our solution, we kind of check the quality of the audio calls. So let's imagine that we mark some calls as bad quality, and we cannot take further actions. We need to have employee who will review the results of our solution before taking actions. So the lesson learned here is that compliance cannot be the afterthought. It needs to be integrated with the project planning and management because it might impact the shape of your solution, and it for sure takes some time to prepare all the documentation. Another challenge was making sure that our solution is secure. So we implemented the private VPN so that all traffics go through secure network. Moreover, we have a strong authentication with a multi-factor authentication and with the role-based access control to make sure that only authorized users can access the data. For the AI layer, we implemented the private Azure OpenAI deployments. So it means that sensitive data stays within our subscription. It's not shared with external models. And moreover, we could rely on enterprise-grade compliance and security guarantees. One problematic thing was that in Spain, we had a mono recordings. So it means we had only one single channel and both speakers were mixed together into same track. This is different from stereo recordings, where we have two tracks and we can separate the speakers. So why was it problematic? So let's imagine that we have a conversation and with an inappropriate language, with a swear words or something like this. So from the quality perspective, it's quite important if agent said these words or if debtor said these words. So you can imagine that if agent said these words, it's a big red flag. So we decided to introduce the speaker diarization with a Pianote model, which detects when the speaker changes and groups segments based on the voice similarity. Moreover, we additionally introduced the role classification based on the keywords typically set by agent or by the debtor. So at the end, the solution had a very, very poor quality. The output was based on the timestamp. We have some overlapping segments, so if the debtor and agent said in the same time some words, we couldn't split them anyway. And the speakers were mixed. So we continue our project, and at the end, the speaker diarization was not needed at all, because large language models could separate the speakers anyway with a high accuracy only based on the transcription, so without audio. So it was a quite good solution, and moreover, as we use LLMs anyway, it didn't add some costs to our project. Then we needed to spend some time to choose the right transcription model. So to evaluate models, we were using two metrics, word error rate and character error rate. So the first metric is calculating what proportion of the words were predicted wrongly. The second metrics do the same at the character level. So of course, the lower the better. So we started with Whisper Large 3. We were quite lucky because we did the project in Spain, and these models work quite well on a Spanish language. The first model has the best overall accuracy. It has some problems with our overlapping speaks, but it was the best anyway. Then we decided to test the turbo version of it, and it provided a good balance between the speed and accuracy, but again it has some problems with overlapping text and with it like we're missing some part of words while transcribing. And the last model we tested was a distilled version of the Whisper. So the assumption was that it will be better in terms of time of computing, but it will be the accuracy will be similar. But unfortunately, the Spanish language was not into the standard model. So I tested the Spanish version, and the results were very, very, very bad. We also tested with different configuration of the model. So we enabled the timestamp generation because our audios were quite long. And I compared the word level timestamp with the standard one. And at the end, the results were better for the standard timestamp approach. I also tested 2 different approaches to the longer audios, processing them sequentially versus splitting them into chunks. And as you see, the sequential approach was very, very slow, but the accuracy was the best. And the chunk approach provided much better latency, but it comes with some deterioration with metrics depending on the batch size and the chunk size. At the end, we needed to balance the costs. So I think we have quite nice results when it goes to transcription. We could transcribe 1 hour of audio with roughly 1 minute. Running this on 100-based virtual machines keeps the costs quite low. The key cost factor comes from the AI layer. So each request contains a fixed prompt and the transcription data, which led to a few 100,000 input tokens per day, plus additional output tokens. So at the end, this was the most costly way part of our solution. Another part is the evaluation. So regarding metrics, I already mentioned the word error rate and character error rate for transcription. For an AI analysis, we use the accuracy, precision, and recall because the output was either wrong or right. And additionally, we built some internal application where we can play an audio, see the transcription, see the AI labels, and review them, and save a ground truth. So our lesson learned here is that having reliable ground truth is needed to evaluate the transcription model, to evaluate the prompt quality, and as you saw, we rely on it while choosing the good configuration of models. And here you can see part of this application. It's a simple Gradio application. You can choose the audio either by ID or randomly, and then you can play the audio. You can see the transcription, and you can change it, correct it, and submit to save it as a ground truth. Then we have another part of this application, and here you can see the labels we generated, the example labels. And again, you can see the results, but the user can provide a ground truth data with an additional comment why something is wrong. So this application was used not only for evaluation, but as I told you, the AI Act required to have a human oversight. And thanks to this application, the employees could review the result of application and take actions based on their opinion too, not only on the results of the model. So another part is the AI orchestration. So the problem was that when we did the project, the LLM ecosystem was still quite immature. So this means that we need to implement most of our orchestration by ourselves. We couldn't rely on the other solutions because they were still not stable enough for production use. It means that we needed to implement the execution loops ourselves. We need to handle the failures and retries. We needed to design the batch and parallel processing. We needed to manage the prompt registration and prompt versioning. So it was a lot of work on our side. We also needed to manage the response schema because it was quite important in our solution. And another challenge was the prompt operation. So we treated prompts as a version artifacts, and we kind of version control them in the same way as we do with our models. So it means that if the new version of prompt was created, it was evaluated against the current production one using the ground truth data that I showed you we get from the application. Based on this, we ran some detailed evaluation. We calculated the metrics. So we calculated the metrics for transcription for the AI labels, and we needed to calculate the metric for each extracted field, because in the quality use case and in the compliance use case, we extracted, I don't know, maybe 20, 30 labels. So changing the prompt might impact only a few of them, might impact all of them, etc. So we ran the detailed evaluation. And at the end, we needed to build some CI/CD pipelines. So it means that every time the prompt changed, we triggered automatically the pipeline. And the pipeline took the ground truth data, scored it, and then some metrics were calculated based on this. So every time a new prompt arrived, we ran this pipeline. And at the end, if the results of new version of prompt were better, then we had an approval gate. So someone needed to look into the results and confirm that the model could be deployed to the production. In some situations, the deployment could be forced because sometimes we needed to integrate some changes into prompt. Even though the performance was a bit worse, we needed to deploy a new version anyway. So the lesson learned here is that building end-to-end framework to kind of manage the prompt versioning, prompt evaluation, prompt deployment was crucial, because in real life, the prompt was changing quite frequent, and we needed to take care of this. And that's all from my side. Thank you for today.
Thank you so much, Justyna, for an incredible presentation. And we want to ask you also a couple of questions connected to your presentation, if that's fine. So first up, I was wondering what language or languages did you have to handle during this project? Was it only Spanish, or was it also other languages?
Yeah, it was only Spanish, as we did the project in Spain, but we also tested some quality of transcription with other countries, and it was worse because of the language.
Okay. So a follow-up on that is, would like fine-tuning of these whisper models be an option for higher accuracy at all? Was that something you explored during the project?
So we were thinking about this, but we didn't have enough ground truth data to fine-tune. So we decided to do the project with the standard whisper model, and maybe in the future, when we gather more ground truth of transcription, we can fine-tune.
Right, because these, in this instance, these whisper are open source models, right?
Yes.
So fine-tuning would be a possibility.
Yeah, of course.
And then I was also curious, like, what were the insights then used for, like the results coming out from this project?
So one was this quality use case, and in quality, advisors have a kind of bonus in our company if they follow the rules. So based on the output, they receive the bonus or not. And moreover, it was a legal obligation. So our company is legally obliged to control some of the aspects. So we needed to do this anyway. So in this case, we just automated it.
Right, thank you. And these Whisper models, how accurate or how good are they in actually what do you say, like determined between different people within a call?
But once again?
Yeah, so the Whisper models, how good and accurate are they in like differentiating between two people within the call, or does it happen that they mix up?
No, because like Whisper is only transcribing, it's not detecting the two speakers, so we didn't measure how the quality of the voice impacts the quality of transcription, but to separate these speakers we used LLMs.
Right, okay, yeah, thank you for the clarification.
Yeah.
And with that, we want to thank you so much for being here and delivering this presentation, and we want to give you this umbrella as a gift. Thank you so much for being here. Thank you.
Thank you.